Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi. Okay guys, welcome to electrical machine, chapter single phase induction motor, chapter 3. Okay, I believe you have gone through the induction machine 3 phase and you have understand on the concept, operation and performance of the machines. So now we are proceeding with a single phase of the induction motor. Okay, by right, this single phase motor has been being used widely in the market and by the consumer due to the simplicity of the design and the cost and minimum cost which is occur on the design. So it means that you can find almost everything which use motor which connected to the AC source. It use Barrett AC induction motors, and we can find in the washing machines, disc, compressor, pumps, aircon, freezer, air conditioner, and so on, and all of that, and use AC induction machine. And also in the factory, use in conveyor, use in lift, hoist, whatsoever, which is involve low cost, easy control, and because in terms of speed we can attach with the inverter, and prior to the machine, just after the source we connect to inverter, so we are able to control the frequency that deliver to the motor, so the speed of the motor can be controlled. Okay, theoretically, and we are going to see in terms of how the motor to be started and how the motor should be run and how the performance when it runs and what is the procedure and the methods should be used to start the single phase motor, because in 3 phase we can directly connect to the source, 3 phase source, so the magnetic field will be rotate accordingly to the 3 phase waveform and sequence. So it will directly, if you connect directly, so it will rotate, follows the frequency of the source. But in single phase, you have to provide some sort of starting rotational electromagnetic fields externally, because in the single phase we have only 2 poles, which is north and south. So better if you just connect north and south to the system, it won't rotate because you don't know where to rotate in terms of the direction, and it does not have yet in terms of starting current and on the rotor bar. Okay, we shall see that later. Okay, and then we go to the performance and in terms of how it behaves when it runs. And okay, in terms of construction, both induction motor, either 3 phase or single phase, they have same construction, which is we have stator, provide the core to be wind with the winding of the stator slot on the stator slot, and we have a rotor. So this rotor, either if we have a wound type rotor, so we wind with the coil, but most of it when we just use a squirrel cage induction motor, so this slot will be filled with the conductor bar, either from copper or aluminum. So this is the winding bar or the winding slots. Okay. Okay, we have 2 kind of windings as well. We have main winding, we have auxiliary winding. So for induction motor single phase, it is compulsory to have auxiliary winding if the motor just consists of 2 poles. So if you see here, if the motor comes with 2 poles, so we have to provide some auxiliary winding, which is the starting winding. So we have here, let's say we have 2 poles, north and south here. So this pole will be auxiliary winding poles. Okay. Instead, if we connect to the external and AC source, which is comes in AC, by right at the starting point or starting phase of the motor, So the connection will be connected to the running coil to provide the electromagnetic field, and also it will be connected to the starting coil. This is running coil, this is starting coil. So both will provide with the same source, and it will generate 4 poles here. The first pole, 2 poles north and south, and the other poles of north and south. So we have 4 poles. So it will have a in phase and in certain phase different in terms of this running and starting poles sequence. So let's say if the sequence start on the clockwise, so it start here and jump here and next to the other poles, and it rotates accordingly, then you will generate an electromagnetic force to the bar, and the current will conduct in the bar, and it will turn to the follow the rotating magnetic fields. Okay, so we have main pole and auxiliary winding. Okay, we skip this part first because this part is more to the construction or the lamination of your windings. Okay, in terms of basic induction motor concept, we go through in terms of how the induced torque of the induction motor develop, and how the slip affect the speed of your motor. So the slip actually is the same like 3-phase, and the more the slip means that the slower the rotor will follow, or will follow your rotating magnetic fields and the frequency of the rotor. So we have same equation, which is synchronous speed is equal to how much the field frequency times 120 divided by the number of poles. So in single phase motor, we have only 2 kinds of poles. Minimum is 2, maximum, because we seldomly go to higher than 4 poles, because if we have more poles, we have to put more windings, more slots, and more complex in terms of construction. So generally we have 2 or 4 poles, and then if we need some sort of reduction in terms of the speed at the end user side, so usually we shall use gearbox and reduction gearbox. And let's say the motor is producing 1800 rpm, we need only 100 rpm, so we use a 100 to 1, means that we reduce accordingly to our end user speed. So in terms of speed will be reduced, and the torque will be increased, so that will fulfill the requirement of the loads usually. Okay, here are the induction, the induced voltage at the rotor bar, means that the amount of induced rotor bar voltage on the rotor bar is equal to the how much the velocity of the bar compared and to the magnetic field, then the intensity of the flux and magnetic field intensity, and the length of the conductor of the magnetic fields. Means that the rotor, if you have a longer rotor and longer rotor bar or longer rotor coil, so you have a higher induced voltage. And the induced torque, the strength of the torque, is equal to the constant times your magnetic field intensity times your rotor stator times rotor magnetic field and intensity. So it also include equivalent to the converted power over omega m, speed of your motor, or if you measure at your air gap, so P air gap, the power of air gap over terminal speed. So this one you can find in your power flow diagram. So just like your 3-phase motor power flow diagram, right? So we have here at normal operation, both the rotor and stator magnetic fields, which is BR and BS, are rotate at synchronous speed, while the rotor itself turns at a slower speed, because both BR and BS are the magnetic field, and the magnetic fields which rotate based on the frequency of your source. It's just when we measure in terms of their speed, in terms of the speed of your motor, the shaft end of your shaft. So for sure we have some sort of slip. So when we have slip only, we have induced magnetic fields. Okay, we shall go this question later. So we proceed with the next note. So we shall go or discuss in terms of how the starting methods of the single phase motor. We have three kinds of majorly being used in the market. So the starting method usually will be in kind of split phase windings application on the motor, or we have a capacitor type motor, or we have a shaded stator poles motor. So this shaded poles usually used on the small power handheld machines. Capacitor type on the cheaper kinds of motor, and split phase maybe in the higher rating kind of motors, but slower speed. So these three techniques being used widely in the market. We have other kind of stacks, but we shall see this kind of stacks and in terms of their performance and in terms of the behavior later on, because this is the three types of kind of steps or methods being used widely in the market. So in the starting technique differ in cost and in amount of the starting torque produced. So these three kind of techniques, they differentiate in terms of their starting torque. Depends on the load. How the bigger the load, so we shall use some kind of starting to overcome the load. Because most of the motor, induction motor, will be attached to the load, and once it's run, it usually will drag or will consume or will operate on the full load of the system. And like if let's say we have a DC motor, maybe we connect once the load, the motor at certain speed, but in terms of AC induction motor, usually it connect to the load. Once start, you start with load. And as you can see in terms of compressor, in terms of your air condition, your refrigerator, it start with loaded already, and so it consumes very high current. So and you need very high torque. So we have to consider this kind of starting current and starting torque. Okay, starting method of a single phase motor. We have a split phase winding. And split phase winding, we have a centrifugal switch. So one branch will represent one pole. So this second branch will represent second pole. So both are in terms of layout, it will be like this. So we have one pole here and second pole here. Okay. Okay, so this starting method of single phase, split phase winding. So we have here main winding, we have here auxiliary windings. Once the centrifugal switch is designed to activate or deactivate, once the speed will reach certain kind of speed. If you can see here, so the main winding plus the starting windings, and the main winding and the starting winding here will be connected together, so it will introduce a very high torque, and this is the torque in this torque, which is almost 150% in terms of torque the system, compared to if you just use only main windings, and only main windings which is very low, and if you connect your load, so for sure you cannot operate your load, and because the starting torque is very low. After it reach certain speed only, the torque will build up and it's able to draw the load, or to drag, or to force the load. If you connect directly with the only main windings, so you're not able to operate the load. So that's why we have main plus starting windings here. And then after it reach certain speed, so this is certain speed, maybe this may be after 80% of the speed, so the switch here will be disconnected.